Every day, millions of people open their refrigerators, grab yesterday's dinner, and place it in the microwave without a second thought. It's one of the most routine habits in modern life, convenient, fast, harmless, or so it seems, because while that plate spins inside your microwave, something you can't see, smell, or taste is quietly happening. The food that looked perfectly safe moments ago is undergoing a transformation at the molecular level. And what researchers have discovered about this invisible process has begun changing how scientists think about one of our most trusted kitchen tools. This isn't about bacteria, it's not about food poisoning in the traditional sense. The issue is far more subtle, and that's exactly why it went unnoticed for so long. Let's start with something simple: chicken. Imagine preparing a healthy grilled chicken breast on Sunday evening. You store the leftovers in the fridge. By Tuesday afternoon, you reheat it for lunch. The texture is slightly different, maybe a little drier, but otherwise it seems fine. You eat it. Move on with your day. But here's what you didn't see. When protein-rich foods like chicken are cooked, once heat causes the protein molecules to denature, they unfold and restructure. That's normal. That's how cooking works. But when you reheat that same chicken a second time, especially at high temperatures, those proteins undergo another round of structural changes. And this time, something unexpected can occur. Researchers have found that reheating certain protein-dense foods can trigger the formation of compounds called heterocyclic amines, HCAs for short. These are chemical byproducts that form when amino acids, sugars, and creatine react under high heat. Now here's where things become concerning. The International Agency for Research on Cancer has classified several HCAs as probable human carcinogens. In laboratory studies, animals exposed to high levels of these compounds develop tumors in multiple organs: colon, breast, prostate. Human epidemiological studies have shown associations between frequent consumption of foods high in HCAs and increased cancer risk. That alone would be significant. But the story doesn't end there. Because chicken isn't the only food that behaves this way, let's talk about rice. On the surface, rice seems like one of the safest foods you could eat. It's a staple for billions of people. It's bland, neutral, inoffensive, but rice has a hidden vulnerability that most people never think about. When rice is cooked and then left at room temperature, spores of a bacteria called Bacillus cereus can survive the cooking process. These spores are heat resistant. Boiling water doesn't kill them. And when rice cools down slowly, say, sitting on the counter for a few hours, those spores germinate. They multiply. They begin producing toxins. Reheating the rice later won't destroy those toxins. The Centers for Disease Control has documented thousands of cases of Bacillus cereus food poisoning, and rice is one of the most common culprits. Symptoms usually appear within hours: nausea, vomiting, abdominal cramps. Most cases resolve on their own, but in certain situations, particularly among young children, elderly adults, or immunocompromised individuals, the effects can be more severe. Here's the part that surprised even microbiologists. The issue isn't reheating itself. The issue is time, the window between cooking and refrigeration. If rice is moved to the fridge within an hour of cooking, bacterial growth is minimized. But if it sits out cooling slowly on the stove, left in a rice cooker on warm mode, that's when the risk increases. Reheating can't undo that. Now let's shift to something most people consider one of the healthiest foods in the world: spinach. Spinach is loaded with vitamins, minerals, and antioxidants. Nutritionists recommend it constantly. It appears on every superfoods list. And when it's fresh, it absolutely deserves that reputation. But spinach contains something else: nitrates. Nitrates themselves aren't inherently dangerous. In fact, they're naturally present in many vegetables and even play beneficial roles in cardiovascular health. The problem arises during storage and reheating. When spinach is cooked and then stored, bacteria can convert those harmless nitrates into nitrites. And, under certain conditions, particularly when reheated nitrites can further transform into nitrosamines. Nitrosamines are a different category of concern altogether. The World Health Organization and multiple cancer research agencies have identified nitrosamines as potent carcinogens. They've been linked to increased risks of stomach cancer, esophageal cancer, and other malignancies. The European Food Safety Authority has issued recommendations specifically about reheating nitrate-rich vegetables for this reason. Here's the critical nuance. Eating fresh spinach, perfectly safe. Cooking spinach and eating it immediately, also fine. The issue emerges when cooked spinach sits for extended periods and is then reheated. That's the sequence that creates the chemical environment for nitrosamine formation. And many people do exactly that: meal prep a big batch of sautéed spinach on Sunday, store it all week, and reheat portions daily. Most have no idea this quiet transformation is taking place. But there's one more food that deserves attention. And this one might be the most surprising of all. Eggs. Eggs are a breakfast staple. Scrambled, boiled, fried, they're one of the most versatile and nutrient-dense foods available. High in protein, rich in essential amino acids, generally considered a cornerstone of healthy eating, but eggs are also highly susceptible to oxidation. When eggs are cooked, the heat exposure can cause some oxidation of cholesterol within the yolk. This produces compounds called oxysterols. In small amounts, these aren't necessarily problematic. But when eggs are reheated, especially at high temperatures, or multiple times the concentration of oxysterols can increase. Research published in the Journal of Agricultural and Food Chemistry found that reheated eggs showed significantly higher levels of oxidized cholesterol compared to freshly cooked eggs. Why does that matter? Because oxysterols have been studied extensively in the context of cardiovascular health. They've been associated with increased inflammation, endothelial dysfunction, and atherosclerosis. Some animal studies have even suggested links to neurodegenerative conditions. Does that mean reheating scrambled eggs once is going to cause a heart attack? Of course not. Biology doesn't work in absolutes like that, but it does mean that the cumulative effect of repeatedly reheating protein-rich, cholesterol-containing foods may contribute to oxidative stress over time. And oxidative stress is one of the foundational mechanisms behind chronic disease. So here's the broader question. If these transformations are happening invisibly, if the food looks the same, smells the same, even tastes relatively the same, how is anyone supposed to know? That's exactly the problem. For decades, food safety education focused almost entirely on bacterial contamination. Wash your hands. Cook meat to the right temperature. Don't leave dairy out too long. Those guidelines are important. They've saved countless lives. But the chemistry of reheating? That's a newer frontier. And it doesn't come with the same obvious warning signs. There's no smell of spoilage, no visible mold, no immediate illness in most cases, just a gradual, invisible accumulation of compounds that researchers are only now beginning to fully understand. Let's take a step back and look at what all four of these foods have in common. They're all nutrient-dense, they're all frequently meal prepped, they're all routinely reheated, and they all undergo chemical changes during that reheating process that don't occur during the initial cooking. That last part is key. Cooking food once transforms it. That's expected, that's necessary. But reheating, particularly in a microwave where heat distribution can be uneven and certain areas reach very high temperatures, can push some foods into a secondary chemical reaction zone that fresh cooking doesn't touch. And the microwave itself plays a unique role here. Unlike an oven or stovetop, which heat food more gradually and evenly, microwaves work by agitating water molecules. This creates rapid localized heating. In some spots, the temperature spikes much higher than you'd expect. In others, the food barely warms. That unevenness isn't just a texture issue, it's a chemistry issue. When proteins in chicken are exposed to those microwave hotspots, HCA formation accelerates. When spinach heats unevenly, pockets of higher nitrite concentration can develop. When eggs are zapped at full power, oxidation intensifies in the hottest zones. It's not that microwaves are inherently dangerous, it's that the way they heat food creates conditions that can amplify these chemical transformations. So, what does all of this mean practically? Does it mean you should never reheat leftovers again? No, that's neither realistic nor necessary. Does it mean these four foods should be completely avoided? Also, no. What it does mean is that small changes in how you handle, store, and reheat food can significantly reduce your exposure to these compounds. Let's start with chicken. If you're meal prepping chicken for the week, consider these adjustments. First, cook it at moderate temperatures rather than charring it at high heat that reduces HCA formation during the initial cooking. Second, when reheating, use gentler methods. A stovetop with a little added moisture. An oven at lower temperature. Even a microwave on 50% power rather than full blast. The goal is to warm the food, not cook it a second time. With rice, the strategy is even simpler. Cool it quickly. If you've just made a big pot of rice, don't let it sit out. Transfer it to shallow containers and refrigerate it within an hour. When you reheat it, make sure it's steaming hot all the way through. That won't eliminate preformed toxins, but it does kill any remaining bacteria. And honestly, if rice has been sitting at room temperature for more than 2 hours, it's safer to discard it than gamble. Spinach follows a similar principle. If you're cooking spinach, eat it fresh when possible. If you're storing it, keep it refrigerated immediately and consume it within a day or two. When reheating, use the lowest effective temperature. Better yet, add cooked spinach to cold dishes, salads, wraps, grain bowls, where reheating isn't necessary. Eggs are perhaps the trickiest. If you're making a big batch of scrambled eggs or a frittata for the week, be mindful of reheating frequency. Once, probably fine. Multiple times over several days, that's where oxidation compounds start accumulating. A better approach might be to cook eggs fresh each morning. It only takes a few minutes, or to prep other elements of breakfast and cook the eggs last. Now, here's an important clarification. None of this is about creating fear. It's about informed decision-making. The human body is remarkably resilient. It's equipped with detoxification systems, antioxidant defenses, and repair mechanisms that handle occasional exposure to these compounds without issue. One reheated chicken breast isn't going to trigger cancer. One bowl of leftover rice won't lead to chronic illness. But patterns matter. Cumulative exposure matters. And for people who meal prep, extensively reheat food daily, and rely heavily on microwave cooking, these small chemical changes can add up over months and years. The science here isn't about absolutes. It's about probabilities. It's about reducing unnecessary risk where simple alternatives exist. And that's ultimately what makes this topic so important. Because unlike many health risks, genetics, environmental pollution, aging, this is one area where you have direct control. The choices you make in your kitchen every single day influence your long-term exposure to these compounds. Let's zoom out one more time. The broader lesson here isn't really about 4 specific foods. It's about understanding that food is chemistry. Every time you apply heat, every time you store something, every time you reheat it, you're participating in chemical reactions. Most of those reactions are harmless, some are beneficial, but a few create byproducts that science is only now beginning to fully map. The researchers studying HCAs didn't set out to demonize chicken. The microbiologists studying Bacillus cereus aren't trying to eliminate rice from the human diet. The food chemists measuring nitrosamines in spinach aren't anti-vegetable. They're simply revealing what's actually happening at the molecular level. And once you see it, you can't unsee it. That awareness changes behavior not out of fear, but out of respect for the complexity of something as seemingly simple as leftovers. So here's the final takeaway. Your microwave isn't the enemy. Leftovers aren't inherently dangerous. Meal prep isn't a mistake. But the assumption that reheating food is always neutral that it's just a matter of convenience with no chemical consequences, that assumption is worth revisiting. Because the truth is more nuanced. The truth is that heat changes food, and sometimes the second round of heat changes it in ways the first round didn't. The food still looks the same, but at the molecular level something shifted, and now you know what scientists know. The question is, what will you do with that knowledge? Maybe you'll start refrigerating rice faster, maybe you'll reheat chicken more gently, maybe you'll eat spinach fresh instead of storing it for days, maybe you'll cook eggs in smaller, fresher batches, or maybe you'll decide the convenience outweighs the risk, and that's okay too. This isn't about perfection, it's about awareness. Because the most dangerous health risks are the ones we never think about, the invisible ones, the gradual ones, the ones that accumulate quietly in the background of our daily routines. This was one of them. Now it's not invisible anymore. If this changed the way you think about something as routine as leftovers, you'll probably find the next investigation just as eye-opening.